Module 8, Lesson 3 covers similar triangles and slope. According to our pacing guide, this one should be super quick, and I like super quick. The maximum slope for a hand-propelled wheelchair ramp should be 1 inch of rise for every 12 inches of length. This actually became a big deal on our beaches. Gulf State Park built this nice long ramp going out to the beach from their parking lot at the, Romar Overlook? Nope, wasn't it? It's a 161 Overlook, which y'all have a different name for. And that slope that they originally built, well, it ended up being too great. So they had to take and buy a whole bunch more wood and jack up that ramp so that it went out much, much further on the beach, making it a much more gradual slope, all to get down to the sand where you can't take wheelchairs on the sand anyhow. But they did meet the requirements for the Individuals with Disabilities Act, because the slope of their ramp was no more than a rise of 1 inch for a run of every 12 inches. Now, our inquiry question asked, how does the slope compare between any two pairs of points on a line? Well, we've talked about that in the previous lesson and gave all kinds of definitions for slope, and here we're going to look at it involving a right triangle. The graph shows the designs for a skateboard ramp. Each unit represents 1 foot. Ryan wants to use the design to build his own skateboard ramp. However, he wants the ramp to be longer than the one showed, but not any steeper. Do you think it is possible to build a skateboard ramp to Ryan's expectations? Absolutely, because all you have to do is continue this line out going this direction. It can be longer, it's going to be higher, but it's not going to be steeper because the slope is going to remain the same. Now, this sketch shows the same triangle as one of the plans that Ryan ordered. AC represents the length of the skateboard ramp. So take a look here. You got AC is going to be the length of the skateboard ramp. That's going to be this distance right here. Meanwhile, they want to find and record the slope between points A and B. Drag point B to increase AC and find out how the size of the triangle is going to change. Make predictions about what happens to the slope. So we're going to take and drag point B, and you can see that even though the length of the ramp is getting longer, the actual slope of it does not change at all, because it's going to be the same exact rise over run ratio. Now, if we were to take the same thing again, you can see there's the line that represents the slope, and the value of the slope is a 0.5, also known as 1/2, and it doesn't matter how long we make that triangle or the ramp go, the slope stayed the same. The slope was a constant 0.5, or rise of 1 to every run of 2. And from here we move on into the lesson a little further, where we're going to learn some definitions. The first definition we're going to have is similar triangles. When figures have the same shape but not necessarily the same size, they're going to be called similar figures, meaning that the ratio between the side lengths is going to be the same and the angles is going to be the same. Similar figures have what we refer to as corresponding parts, and I do need to make that one green as well, because that's the color we choose for our definitions. So in words, we can see that if two triangles are similar, then their corresponding angles are congruent and their corresponding sides are going to be proportional. In a model, what are they going to show us here? We've got two different triangles. You can see that one of them is clearly bigger than the other one, but their angles, corresponding angles, are congruent. One arc for the angles on the left. The top angles have 3 arcs, meaning that they're congruent. And the bottom right angles, they have got 2 arcs, meaning that they're congruent. Also, the ratio between the side lengths are the same. 10 divided by 5 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. That means these are indeed going to be similar triangles. Don't get stressed out. We're going to talk more about this. The triangles A, B, and C and triangle B, D, and E. Let's just stop right here for a second. This one here, they use the word triangle. This one here, they use the symbol triangle. It's because this one starts off a sentence. You cannot use the symbol for triangle when starting off the sentence, so they had to use a word. That's why this says triangle ABC in a word, and this one says triangle BDE using the symbol triangle. Anyhow, they're both right triangles, and they fall on the same line in the coordinate plane. These right triangles are called slope triangles, and slope triangles are triangles that are similar, so their corresponding sides are going to end up being proportional. So you've got these two triangles, they have the same slope, they're on the same line, which means any triangles you create, right triangles you create along the slope of this line, they're going to end up being similar triangles. Now the question they ask us is, how can we use slope triangles to find the slope of the line, and is the slope of the line the same no matter which slope triangle is being used? Explain and then draw other, yeah, okay, sure. Well, the initial answer is all we have to do is rise over run, or y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. What's the textbook going to end up using? They are going to, tease us for a minute. In words, it's going to say the ratio of the rise to the run of the two slope triangles formed by the line is going to be equal to the slope of the line. So we've already established that they have the same slope. On a graph, we can see that I have no idea what they're showing right there on the graph. Oh, yeah, there's a little bitty triangle. You got a big triangle, you got a little triangle. They have the same exact slope. And then for an example, if you were to take the large triangle and find its slope, you rise divided by run, you get a slope of -2. If you took the little triangle, found its slope, you do a rise divided by run, you get -2. And if you took the slope of the whole line going from this point down to that point, you still do rise divided by run, and you still get the same -2 for a slope. Now let's watch another video put on by our textbook.
Similar triangles. You can use slope triangles to show that the slope of a line is the same between any 2 points on a non-vertical line. First, draw a line on the coordinate plane. Then construct a right triangle on the line using any 2 points on the line. Label this triangle ABC. Construct another right triangle on the line. Label this triangle CDE. Triangle ABC and triangle CDE are slope triangles, and slope triangles are similar. Write the ratio of the rise to run for each triangle. The rise of triangle ABC is 4, and the run is 3. So the ratio of the rise to the run is 4 to 3. The rise of triangle CDE is 8, and the run is 6. So the ratio of the rise to the run is 8 to 6, which simplifies to 4 to 3. Notice that the ratios are equal. In fact, any slope triangle drawn on the line will also have the same ratio. Since the ratios are equal, any 2 distinct points on the line have the same slope.
Well, okay then. That looks pretty good. So let's look at example 1. It says the graph of line T is shown. Use these similar slope triangles to compare the slope of segment AC, that's right here, to segment CE. That's going to be right here. So what do we have to do? We have to solve to get the slope of both points. First, they compared the rise AB right here, which is going to be 3, to the run BC right here, which is going to be 2, and that gives you a slope of line segment AC is going to be 3 over 2. So that means that this little section right here, That's going to be 3 over 2. Next, we're going to take and find the slope of section 2, where we got the rise of CD. That's 1, 2, 3, 4, 5, 6. So my rise is going to be 6. And my run is going to be 1, 2, 3, 4. It's going to be 4. And of course, that simplifies to be 3 over 2, which is the same exact slope we got doing it the other way. From there, we can take and look and say that what is the slope of line T going to be? The slope of line T is going to be 3 over 2. Any point along that line is going to have the same slope of 3 over 2. Now with that, we're going to reset this problem, and you are going to pause the video and do extra example 1 on your own. Go ahead and do that right now, please. So let's take a look. The slope of segment AE, that goes from this point here all the way to this point here. So we're going to rise 1, 2, 3 over a run of 1, 2, 3, 4, 5, 6. So it is a 3 over 6, also known as a 1/2, because 3/6 of course simplifies to be 1 over 2, except that the segment BC, that's going to be a rise of 1 and a run of 2, so you get the same slope of 1/2, 1 over 2, except that, and then we can say therefore the slope segment AE is going to be equal to segment BC. They're both going to simplify to have a slope of just 1/2. In example number 2, they're dealing with a roof, and it says the pitch of a roof refers to the slope of the roof line. Choose 2 points on the roof, find the pitch of the roof shown, then verify the pitch is the same by choosing a different set of points. So we have point T, U, S, and R, 4 different points we can choose to work from. So using point TU, you can see that the rise here was 1 to a run of 2. That gave them a slope of 1 over 2. So the slope of the roof is going to be, let's get a fraction going here, 1 over 2. And accept and check. That part checked. Well, that was exciting. Now we're going to take and pick another point to verify we have the same slope. For that one, they're using points S and R, which is going to be this one right here. It has a run of 1, 2, 3, 4, a rise of 1, 2. So a 2 over 4, that's going to simplify to be 1/2. So we're going to put in another 1/2 right here. 1 over 2 again. Check that answer. That one's the same. From there, we can say that the slope of TU is equal to the slope of segment SR. It doesn't matter which 2 points along the line of that roof you pick, you're always going to get the same slope. Last problem, pause the video, find the solution to this problem. Alright, we're dealing with a teeter-totter here, and the first pair of points are going to be points G and H. And if you take a look here, you've got a rise of 1 divided by a run of 3. And yes, you should be writing your formulas for this. So the slope of that one is going to be 1 over 3. Now the second pair of points is going to have a rise of 1 and a run of 3 again. So you get the same exact slope. If they gave you the same size triangle, of course you're going to have the same slope. Anywhere along that teeter-totter you go, you're going to get a slope of 1 to 3 until some big kid sits down on the other side and launches a poor little tiny thing off into the sky, and they go and like touch the moon and whatnot. But until that happens, we've got, let's go ahead and plug this one in, the same slope of 1 over 3 for both of them. Check it. Easy math. That's it for this lesson. I'll see you in class tomorrow. Becoming ready to ask any questions of things that you don't understand.